More section 4.5. Here, we're going to be working with, we've already done this use substitution thing, but now what happens if it's a definite integral and we're doing use substitution? And then our second goal, this video, is going to also hit what happens when the use substitution needs to get a little bit more complex. We're going to hit those two. Problem number 1 will hit goal A. Problem number 2 will hit goal B. So problem number 1, let's pretend for a second like we don't see these bounds. Let's just pretend like the bounds aren't there. So if that's the case, do you have an inside function? You bet. U is equal to x squared plus 1. du over dx would be the same as 2x, so du would be 2x dx. Do we have 2x dx in the problem? No, but we definitely have an x dx in the problem. That x dx is going to be the same as half of a du. So let's throw that in there. So if I do that, I think what I've got is I'm integrating. And if I want to write everything in terms of u, this is the thing that's going to be a little bit tricky. I'm going to, for a second, ignore the bounds, but I'll address them in just a minute. I've got 1/2 of du. Whoops, I was going to do this in red. So I've got 1/2 of du that's going in place of the x and the dx. So that part's already taken care of. The x and the dx are already done. Okay, and then I've got this quantity that's being squared that has a u inside of it. But here's the thing that's going to be a little bit tricky, and you need to be prepared. If you're going to put bounds in this step, remember these are x values. This is x equals 2. This is x equals 0. So if you are technically going to be rewriting this integral all in terms of u, then if you're going to put these bounds here, you better do one of two things. You either better say x is equal to 2 right here and x is equal to 0, or change them. We could go two ways at this point. We could go two ways. We could say, well, wait a minute. If x is equal to 0, u would be equal to 0 squared plus 1, or 1. If x is equal to 2, the upper bound, u would be equal to 2 squared plus 1, or 5. The other thing that you could do is you could rewrite this integral. So we go two directions with this. We could say that we have the integral going from x equals 0 to x equals 2 of 1/2 u squared du. Or we could say we're going to integrate still a 1/2, still a u squared du, but you could say u is going from 1 to 5. The bottom one is technically more correct than the top one is, but you can work them out either way. If you work out the top one, well, let's see. So I've got a 1/2, a 1/3 u cubed, and I'm evaluating that thing for x is going from 0 to 2. Well, put your u back in, 1/6 of x squared plus 1, quantity cubed, and evaluate your bounds, 0 to 2. That's one way to handle it. And if you did that, you'd throw your values in, you'd get your numbers. The other way, with your u's, is you could say, all right, here's 1/2, 1/3 u cubed, but this time I'm going from 1 to 5. Well, if you're going to use this method on the bottom, I've got 1/6 u cubed, and I'm going to plug in my x equals 1 and my x equals 5, and I'm going to end up with 125, whoops, sorry, I forgot the 1/6. 1/6 times the quantity, 125 minus 1, and I'll end up with about, 124 over 6, which some people are probably going to want me to make 62 over 3. Doesn't matter if you reduce it or not, I guess. Whereas if you do it up on the top, You're going to plug your 2 in. If you plug your 2 in, you're going to get, let's see. You're going to end up with, wait a minute, I think if you plug this in, you're going to end up with the same thing. So what you have there is you have 2 different ways to get to the same place. But the key is there, if you're going to rewrite the problem using all u's, watch those bounds. I can tell you beyond a shadow of a doubt that there will be a multiple choice problem on that AP exam where they're going to tell you to rewrite an integral all in making this particular substitution. And if you do and you forget the bounds, you're not going to get it right. So just watch out for that. Watch your bounds. Second one. The second one, do you have a function inside of a function? Yes. Okay, so let's make u 2x minus 1. So then du is 2, and I'm going to du over dx, sorry. So du is 2 times dx. Do we have 2 times dx in my problem? Well, I mean, I guess I could have. I could say, here's dx. Do I have that? Yes, I do. So how can I represent dx? Dx would be the same thing as a half of a du. So if I'm rewriting so far, I've got the integral of, let's see, dx would be the same as a half of du. I've got, on the bottom of this thing, I have the square root of u. The problem is I still have this x up here on the top that I haven't accounted for. So here's your first little exercise in what could I do. My challenge is I need that problem to be rewritten all in terms of u. So what am I going to do with x? This x and this x are the same. So if that's the case, let's solve this equation for x. If u is equal to 2x minus 1, then u plus 1 is equal to 2x. X is equal to u plus 1 divided by 2. So let's rewrite this integral. So I now have the integral, let's do black, the integral of, let's see, fraction, u plus 1 over 2 on the top, square root of u on the bottom, du on the end, 1/2 out in front. Well, now u plus 1 over 2, maybe we ought to pull that 1/2 out also. So here's your integral. I have a red 1/2 and a du, if you're wondering where that came from. And I also have a green 1/2. So let's put a red 1/2 out in front. Let's put a green 1/2 out in front. And let's integrate u plus 1 over square root of u, or u to the 1/2 du. Have we ever done an integral like that before? Yes, we have. It's been a while. But 1/4 integral, how about if we split it, make 2 fractions? U over u to the 1/2 would be u to the positive 1/2, plus 1 over u to the 1/2 would be u to the negative 1/2 du. Now let's use our power rule. So power rule, 1/4, integrating u to the 1/2, add 1 to the power u to the 3/2, divide by the power 2/3 u to the 3/2. Add 1 to the power u to the 1/2, divide by the power, divide by 1/2 would be the same as multiplying by 2. Add those together, and somewhere along the line we're going to have to remember to throw in a plus c. And now if you distribute and put your stuff back in, what have we really got? Well, let's see. So 1/4 times 2/3 would be, what do we got? 1/6 of the quantity to the 3/2 plus 1/2 of the quantity to the 1/2 plus c. What's that quantity? Go all the way back to your original u. The original u is 2x minus 1. Put that back in where you see your u's. And there is a more complex u substitution. So 2 pretty heavy-duty things here with u substitutions and watching out for our bounds with problem number 1.